Hello, welcome to Dom Solar. I'm Stefan Arroway, and today we'll be following the training session, Helios B². I will introduce you to the different parts of the system. We'll also look at a slideshow and some layout examples. Helios B² is certified with a technical assessment for BACSEC and an EUTN for panel sandwich. This is a system that is only installed in landscape mode. It is on the green list. We are generally looking at a maximum purlin spacing of about 2 meters, but we review each project to ensure it meets the purlin spacing requirements. It is only installed on trapezoidal sheet metal with a minimum wave crest height of 35 millimeters and a maximum height of 45 millimeters. You have 333 profiles and 250 profiles. If you have a project less than 3 kilometers from the sea, we will have you fill out a small document. It fits on 1 page, actually, to then send to ArcelorMittal, who is our passive supplier. This will allow you to know whether it is guaranteed or not, or if we need to provide additional protection. Protection for the rails or supports. But before talking about the system and installation on the roof, there are preliminary studies. And what we ask of you in these preliminary studies is to provide us with as many documents as possible, meaning the exact location, the structural plans, and even some photos if the building already exists, how the tray is fixed, its relation to the purlins, what types of purlins, photos of the ridge. It's really very, very important for us to see whether a particular part can or cannot be installed on our roof. So it's good to have photos of the ridge. You should know that with Helios Velo, the ridge cap must fit the crest of the corrugation, rest on the crest, and there should not be any upward extension. You need to know whether the ridge piece can be installed on the cladding sheet and whether it will be fixed to the purlin or not. The types of purlins as well as the type of tray fixing are also important. Anything like clips or roof hooks can cause problems. The clips, we won't be able to install the system, Helios 5.2. With roof hooks, you'll need to check if we can place our support right next to them. It's important to send us this information along with the purlin spacing, and also, if possible, to have at least the ridge cover sheet measured, to know whether it will be attached to that specific ridge purlin or not, either in PDF or DWG format. Once we've done the preliminary study and the quote is signed, we'll create the final layout for you. We prepare the bill of materials. We will include the building dimensions as well as the rails that come with the system. Helios B² uses rails either 3PV or 4PV. So rather than giving you the dimensions, we'll specify instead the 4PV or 3PV rail. The Helios B² system is spliced along the slope, meaning each rail will be spliced together. Whether it's the 3PV rail with the 4PV rail or only 3B rails, depending on your configuration, we will have supports that fit the crest of the corrugation and then a threaded support that will be placed on the support sheet and fixed to the purlin. You don't need to add stitching screws to the tray. You really just position yourself right there where the tray is fixed, that is, to the purlin. Earlier, I told you the profile of the tray can have a wave height of 35 or 45 millimeters between the top of the tray and the support, which was actually designed for a 3.45 tray. We will insert a 5 or 10 millimeter compensator, depending on the height of the project. You have locking keys. We'll look at this in detail in a moment. Locking keys that allow you to slide the rails out and also to position themselves between the support and the rail. And then there are fixed points that you'll find on each rail at the beginning of the first purlin encountered for each rail. That means if you have 3 rails on the slope, you'll have 3 fixed points, and these fixed points are 2 small torque screws. It is forbidden to use impact drivers. Only standard drill drivers are allowed. And the Helios B² system, since it is spliced on the slope, each rail has overhangs that must be respected. For the generator side overhangs, you can have an overhang of up to 70 centimeters between the axis of the purlin and the end of the rail. And at the bottom of the generator, between the first purlin and the end of the rail, you will have 59 centimeters. Regardless of these overhangs, your module will have an overhang of 50 centimeters, whether at the top or the bottom. The splicing of the rails is done either before or after the purlin. A rail splice is about 26 centimeters, and it is never done directly on the purlins. That's why it's important to have the structural plans. What's important before starting is to check your roof. How big is your roof going to be? How big is your generator? And you'll need to check this on your roof already to see if everything fits properly, how you started in relation to our plans, and what the distance will be between your first module and the back edge. We recommend, and everyone has their own method, but we recommend creating 2 gauges. The length of the module plus the gap between the rails. I'll be able to show you this directly on the screen. This is for a module that's about 1665. And on each gauge, we made exactly the same one with a zone between 0 and 13 centimeters. So this is your module's edge. Between 0 and 13 centimeters, no rail fasteners, no supports. Between 13 and plus 33 centimeters, so between the edge of the module and plus 46 centimeters, you have an area where you can place your supports. Same thing on the other side of the gauge, we have those same 13 centimeters, 33 centimeters, and what we've added is the gap between the columns of your modules. By default, we'll set 9 millimeters between the module columns. If you want more, just let us know during the preliminary study. So you create 2 gauges with their markers and the gap between each column. Of course, you need 2 technicians because the first one who will place the gauge on the first module column will set his gauge, mark the necessary areas, and the other technician will place the second gauge against the first. And you'll need to have wave markers as well. Generally, under each module, you have 1 meter between the beams. What will happen at some point is that your marker will end up between 2 zones. So if I redraw your gauge a bit here, you'll have a marker between 2 zones. You'll hesitate. Should I take this one that's closer to the frame or the second one? You'll want to look at the second marker on your gauge instead. And normally with the back 333, it will fit on a single wave. So you'll be able to mark your reference point here. And since you know it's a back 333, you'll need to leave at least 3 waves free. And then you can place your gauge, your marker, it exists. 3 or 4 waves. It depends on how the gauge falls. But in any case, you should never leave less than 1 meter, 1.33 meters or 1 meter. It's a good idea to have 2 spray paint cans, one to mark the waves of the tray and another in a different color to mark the spacing between your modules. Earlier, I told you you need to check your roof along the slope from edge to edge to see how your generator will be positioned. Before attaching your rails to the support and after marking your reference points, you will place your rails on the flat part of the wave as indicated in the layout plan that was provided to you. And exactly according to the starting code, we gave you the typical overhang at the bottom of the generator, and that way you'll see whether your rail overlaps a line or not with the purlins. You'll do this on the left edge, in the middle of the generator, and on the right edge. Because depending on the size of your roof, you might encounter a few surprises when it comes to purlins, which generally, depending on the size and scale of your roof, are often not straight. So it's better to check in several places. And once you've checked that everything is okay for you, you can go ahead and fix the first rail. And we recommend that once you've fixed your first rail, you stretch a chalk line in the middle and at the ends. You have different supports for the Helios B². You have a saddle support, which is for a height of 45, and you also have the ridge saddle support, of course. It's only useful if you're attached to the ridge flashing sheet metal. If the tray has already been installed, you'll need to remove the screw and its saddle to then put back the screw that we will most likely have provided you. It is optional, so make sure to specify that you want the screws to go into the purlin. It's also helpful if you send us the screw that the roofer brought, because we need to give you, if it's a wooden purlin, a screw, a longer one. If it's a metal purlin, you'll need to let us know whether it's a Y purlin or another type of purlin, whether it's 5.5, 6.5 or 6.3. We need to provide you with at least the same diameter or even a larger one. You will always start from the bottom of the generator and the rail. Once you have installed your supports, it clips on. Now everyone clips it at the base, but I'll show you how it can also be fixed. It has a specific orientation and a unique feature. One side is closed and the other is open. Can we provide you with a special clamp, Helios B²? You'll be able to install your rails. Once you've put in all your supports, you can install a first rail and rails in the middle. A rail in the middle, the end rail. Check your diagonals, and once the diagonal is exact, you can install your special infix screws. So 2 small screws on the first purlin at the bottom of the generator, Tox 20. And it's very important that these rails are perfectly aligned, because after that, it's all about splicing. Here I have 3 rail samples. We'll consider this as the same rail. You have the bottom of the generator, always the black shim at the end of the rail, with these 2 little air bots where you can wedge a cable, and then the black stop here, which is used to install the modules. These shims are pre-assembled. You have the bottom of the generator. Here we're in the middle of the generator, and here you have the end of the generator, where this well-known black shim is not installed. It will need to be installed if you finish your module at this spot, so at the top of the generator. The Helios B² rail has a particular feature. It has 1 closed side and 1 open side. And to install it actually, you have to picture your support here, the B2, a support disassembled with its gasket. Here, PDM, the flat supports to rest properly on the tray, and the well-known compensators, depending on the height of the tray, which you will slide between the support and the wave crest of the tray, if you have a tray with a height less than 45. For the rail, you have to picture a roof slope like this. The rail always clips on the fin side, the closed side. You place yourself directly into the nail weight. And on this side, with the open slots, you will clip it in. And you press here. Now the technicians press down with their foot. You don't kick it, but you press down with your foot. And you clip yourself in like this. And then it slides inside the rail. So if you have 2 or 3 rails, you clip them in, support by support, and then it slides in. You also have the option to ask for the clamp and just the 2. You slide it here just under the rail and next to the support. You press down on the round part here. You go into the tip, slide the tip into the rail's groove and press down. You do it all by yourself. Once you're sure that your first rail is properly started, that you've checked your alignment, that everything looks right, your overhangs are correct, you've respected the overhangs, and your joints don't fall directly on the slope, you can fix your first rail. This is the one that will determine everything. Then all your rails at the bottom, you'll need to align them, and after that, it's just a matter of joining them together. It's your first rail that will determine whether you're properly or improperly positioned in relation to your generator. You take 2 small Torx 20 screws and fasten them on each side. You always start with the open gutter, because if you start on the other side, it will slip. So you start here, hold your rail, and go all the way through the support from one side to the other. It's drilled on both sides. So you go in at the lowest possible speed. You start at the lowest speed. If it gets stuck, increase the speed a little and try to keep it as straight as possible. Because if you go in at an angle, you'll break the screw head. If you do break one, usually you'll be able to set this one properly. If you break one, go to the other support to at least put in a second fixed point. You will always find the fixed points on each rail, and so Once you've set your chalk line, you move on to all the rails at the bottom of the generator. You check your diagonals from time to time, but above all, you do everything using the chalk line so it's perfectly aligned. That's very important. For all the supports that don't have a fixed point screw, you'll use a locking key. Your rail is fixed at the bottom of the generator with the 2 fixed point screws. You're working with 3 supports or 2, it depends. For the other supports, you'll slide in a locking key. You always work from top to bottom, and don't forget to press the locking key firmly against the rail. This actually ensures that it can't be removed. So the fixed point screws prevent shifting. The locking key, on the other hand, prevents any up and down play. Next, we move on to splicing. As I mentioned, splicing can be done before or after the blade, and it uses 2 locking keys. That's it. Actually, splicing is done between the bottom end of the rail, let's say, and the top end of the rail in any direction. The distinctive feature of the spliced part of the rail is that you still have your closed side, but for just about 30 centimeters, your rail is notched in that area. That's what allows for the splicing. As I previously mentioned, the splicing process can be effectively done either before or after the support structure. When you have successfully installed your very first rail, and you then come to meticulously install the second rail, it is absolutely crucial to always align it precisely with these 2 distinct holes located here, which are in fact specifically designed for the black shim that will be placed directly and securely into this designated hole. Do not install it like this. By running along the entire length of the rail, because from the very first hole on site, with the speed at which you'll be working, it will actually cut the tabs underneath the black shim, causing it to come off. So instead, when you slide it in, place your rail here, the second one, slide it in, but really come from above and position it right where the 2 holes are and insert it there. But go at a steady pace. Don't go too fast. There's no point. Otherwise, you'll ruin everything. In fact, you'll end up cutting your black shim. So you've clipped your rail in place here, and then you'll insert the 2 locking keys. Now, the locking keys also have a specific orientation. You always start on the open side. Here are the locking keys. You insert the locking keys into the holes. It's not done very often. So 2 locking keys. And above all, don't forget to slide the head into the rail's gutter. So at this point, your rail will be naturally slid here or here, and of course, never on the support that's made for it. For a single rail, there are only 2 rails. Once your rail is slid in, so your second rail is in place, the first purlin, the first support it will encounter, actually, well, that's where you'll put your 2 fixed points back, meaning Torx with the 2 small screws here, Torx 20. Each time after every sliding in, so the Torx screws. Actually, you have 2 on each rail. It's a fixed point, the first one on the first purlin, so at the bottom of the generator, and then after each sliding in. So if you have your sliding here and your purlin here, these are the 2 screws, the 2 fixed point screws. If your sliding is here, you'll have the locking key instead. And if your purlin is at 1.6 meters further away, you'll use your fixed point screw. That's what I'm explaining a bit on the slide here. Outlined in yellow dashes, these are the locking keys. And right after, you have your well-known fixed points. So what we've seen are the locking keys on each support where there isn't a fixed point screw. The locking keys at the splicing point. There remains one area is where you will finish your generator. So either at the ridge with the ridge support, and there you have at least 1 unrolling key. If you can put in 2, you put in 2. If you are using a tray with a height less than 45, don't forget that you also need to place your small EPDN gasket under the ridge support. And then there's still the splicing area. You could very well finish at this splicing area. And there you will put 2 locking keys. You might finish your generator here in this sliding area, barely 30 centimeters. You finish here and you will put them in. In fact, on each side, you have the option to slide in 2 locking keys. It's only in this area that you finish by sliding in 2 locking keys. So here you are at the top of the generator. If you are in the area where there is the well-known curve and the opening of the gutter, obviously you will only be able to use 1 locking key and only on one side. As I told you, in any case, the overhang here at the top of the generator is more than 70 centimeters. If you finish your generator, you have your well-known black alignment stop to add. Don't forget, you need a sheet metal edge nut because here nothing has been provided to allow you to attach it to the rail. This sheet metal edge nut is used for installing the modules later on. The sheet metal edge nut has a specific shape and you slide it into the slot provided at the right end of the generator if you are positioned this way in relation to the slope. And then you clip on your black spacer. Don't forget, in the direction of the slope, the small tabs are always at the bottom and you just clip it on. Once it's clipped on, of course, you won't be able to remove it. We provide you with more black spacers than you actually need normally. And if by any chance some of them break, you can add more. This rail, which is made of Manielis, in fact, in some projects, you will have to cut it. With roof sparrows, you might not need to finish your generator. There will be a larger overhang, and you also won't need to finish your generator at that spot. If you cut it, you don't need to add any extra protection because, as I mentioned, it's made of Manielis. It's less than 2 millimeters thick, and it will protect itself. Let me give you a quick recap of all this. So, the fixed point screws go on the first purlin at the bottom of the generator, whether it's on the purlin, the cladding, or the second purlin. Next, the locking keys go on the other supports, the locking keys for the splices, never directly above the fans, and then each time on every rail, the fixed point screws all the way up to the ridge. Or not, it depends. It depends on how you finish your project. And be careful with overhangs. Top and bottom of the generator, at the bottom more than 59 centimeters for the oral exam. And at the top, no more than 70 centimeters. Otherwise, you have to reach for the purlin above. The sheet metal edge nuts. If you finish your generator properly, add the layout stops and the 2 locking keys. If you are in the sliding zone and then at the ridge, add at least 1 locking key. Once you have installed all your rails, there's the grounding to do. First, the rails need to be grounded. There's a particularity. For grounding the rails, you can also, before fully securing your rails, connect directly to a Helios B² support. This is done with the Revolt from Aramont. You can easily attach this clip to a support, but you should choose the support that receives the fixed point screws. That way, it's a mechanical lock. You only use flexible 6 square millimeter green-yellow wire, or you can place it at the end of the rail at the top of the generator. But this is for each rail column. Previously, there was also the technique of using a lug and bimetal washer, but again on each rail column. With the Helios B² system, you also have the option to install optimizers or microinverters. What you need to be careful about is when you attach it to the rail with a self-tapping screw, make sure to leave at least a 1 centimeter air gap. Once you have grounded your rails and installed your motors or optimizers, all that's left is to install the modules. For the modules, you first need to slide in a clamp, a multi-clamp, and you do this on every other spacer. Then you can install your modules, either starting from the top, that's right. The special feature of Helios B² is that in terms of layout and planning, it allows you to start assembling the generator either from the top or from the bottom. I'll just show the small clamp for grounding. So you never start at the bottom of the generator since it's designed for 2 modules. So at the bottom of the generator, you skip the clamp and you always start on the second spacer. Here is the clamp. It goes here. You have small tabs here for the module frame and then 2 little feet here facing the other way to rest on the rail. And there's only one way to do it. Don't put it here because your little tabs will end up on the plastic spacer. They slide in here into the black spacer. It's made just for that. And then you come in, so your rail will be clipped in. There, we're going to clip it in like this. Install them at the same time as your modules because a gust of wind and everything will blow away. You place your clamp here and then, facing this way, you push it up to the stop and put your modules here. Once it's tightened, you'll be clamped on both sides. So your module will be underneath here. Be aware that for the modules on the slope, you have a module gap between 20 and 26 millimeters. But since you've slid your rails and the clamp is really flush with the black rod, you have very little play for the modules. That's why it's so important that your first rails at the bottom of the array are really well aligned. I can show you directly how to fasten the modules. You use, again, a Torx 25 screw with its clamp that goes here. You just have to screw it in. The module, of course, on one side with its grounding. And then if you were at the bottom of the generator, so rather with this support here, at the bottom of the generator, so whether at the bottom or the top of the generator, it doesn't matter. You finish and we provide you with a spacer the height of the module. Because on one side you'll have your spacer and on the other side you'll have your module. Be careful, the tightening torque is 4 newtons. So make sure to check your tightening. It's not a high speed, it's not a lot of force. So make sure to check your tightening from time to time. As I was saying, screw 6.7 by 70 Torx 25, tightened to 4 Newton meters. Here you have a view of the bottom of the generator. And of course, between the modules, you only have this fastener. You have the same fastener, whether it's between modules or at the bottom of the generator. A quick reminder, as you've seen on several slides, we don't use an impact driver, only a screwdriver or drill. So now we're going to look at a few examples of cabling. For example, on this particular project, where you only have 2 main rails in the steep slope, the slides, well, just immediately after the purlin, we are securely attached to 1, 2, 3, 4, 5, 6, 7, 8, 9 distinct purlins, and even extending all the way up to the very top of the ridge. If it sticks out, if it doesn't stick out too much and you're at the top, there's no need to cut it again. But you can clearly see, for example, a 4 PV rail, a 3 PV rail with 2, 4, 7 modules in places on the purlin with a rail overhang of 43. Here, it's more of a classic setup, a small generator along the length. All your rails here, you have 2 rails under each module. But for us in our Capillanis, we'll only show you 1. Of course, you need it. Several rails in the middle of the generator at the ends, and make sure to put a string line at the very bottom to properly align your rails. Another example of a generator here with attachment on the factory bracket, a separation, it depends. It depends on how your generator is set up. Here you have the rails. We've only shown the rails on one side for you, and here you only have 3 PV panels. That is 2 rails for 3 PV panels, sliding between 2 blades and fastening on 1, 2, 3, 4 blades. You need to be careful here. This is about the overhang. It's not shown, but you know it shouldn't extend above the top of the generator, 70 centimeters. And you're only using standard mounts. What you don't see here is the bill of materials. Maybe you're not on a 3.45 tray, or maybe you're also on a sandwich panel. And there might be EPDM seals under each mount. That will depend on the bill of materials. Another generator with 31 columns and 13 rows. Here you have the rail extending beyond the roof, so you can simply cut your rail and then it will protect itself. Of course, before clipping anything in place, you've already laid out all your rails. So here, rail 3. 3 PVs, 2 rails of 4 PVs each following, 1 rail of 3 PVs. You've laid them out exactly like this on the shadow plate, with a small overhang of 180. Of course, you always need to check on the roof how it will be positioned. For example, here to the right of the generator. In the middle of the generator, you also need to take a good look, and of course, to the left of the generator as well. You need to be very careful about that. And then make sure there are no misalignments at the level of the fins. And the same goes for the cord all the way at the bottom. If you check your diagonals from time to time, that's very, very important for alignment. Here we have 24 columns and 7 rows. Same thing here, we can't see it, but are we attached at the ridge? On some projects, for example, if you're on a single pitch roof or if you're at a fairly high altitude, you might have rail reinforcements. So we'll let you know about that. Here, it's mainly at the edge. You have 3 rails under the module column. So at the ends, on the left edge and on the right edge. Be careful, we also provide you with measurements, usually with the modules between the edge here of the roof and the first module. Make sure to respect these measurements. Afterwards, you may have sent us your layout, how much space you want between each column. But it's very important, we make Capwell notes for every project. So you really need to double check those measurements. If we tell you to start at 70, stick to it, because if you get closer to the edge, you might end up needing not 3 rails, but 4 rails. So be very careful about that. If you have any doubts, really call us back and contact us, the technician, and that's it. You have another roof, it's exactly the same. It's on the same project, except this time we're closer to the ridge, the host. We were going past the ridge, so here you can easily cut your rails to size. That's not a problem at all. So in this case, as we saw earlier, you won't need that special edge nut and the black plate. But you do have to use this plate here because your overhang here is much too large to finish your installation. Second slope, here you're closer to the ridge. So we recommend making the cut rather at the bottom. So there's nothing stopping you from starting off properly at the bottom of the generator, except here, as you can see, we've planned for 2 4-meter rails. So in my opinion, the sliding will work out. If you move up, your generator might end up right in line with the valve. That's why it was done this way. So on the flat part, you'll need to check on your car whether you can or cannot position yourself. Maybe properly at the bottom and make the cut at the top, or the other way around, like here, rather from the top, to see if it doesn't stick out, and you'll have a lot to do. You have to use the entire slope because your overhangs are too large to use only from the fin. Here, the overhang is 50 centimeters for the module, 59 for the rail, so you have to reach for the service fin. Another example of capping, you have skylights. Same thing. Here, the spacing is quite large, so you're even outside certification, since certifications with IoT2 go up to 2 meters. You have rail reinforcements at the bottom of the array, and then you have sections with just a single module, and rails with 4 PV modules in some places, rails with 3 PV modules in others. The best way to start, and to be well aligned at the bottom actually, is your rack of 4 PV modules here, right in the middle of the field. That's where you'll start, and you'll do your alignment from there, exactly everywhere. For the 3 PV racks on each side here, and the 4 PV racks that you'll have elsewhere. It's important to start with this one, because if you start with this one, you'll see that here, you're not quite aligned. You'll be misaligned. Always start with the one where you only have one. It's a special project, but know that you can have projects like this one. And then here, you'll also need to cut your rails. As usual, you position your rails. For example, you position the rail for 4, you position the rail for 3 before clipping or doing anything else. This is really all about carefully laying out your generator. You've thoroughly checked the precise length from one edge to the other edge of your car. You've also checked your slope, and you've carefully placed your rails to see exactly where the joints will naturally fall. This is another slope, it's the Clothier 2, and it's a bit different, but it will always be the same process, with reinforcements, slightly different cuts, and always starting with the rack 4 PV, which is really anchored on the 3 purlins. Plus, you don't have a lot of wiggle room, so that's the one that will really give you a sense of whether you can be. It's the one that will actually tell you how you're going to align yourself at the bottom. Roof with 19 columns and 14 entries with a separation of the generator. Here, we've outlined the entire roof in red for you. And you have rail reinforcements on each column. You have 3 rails per column. That's indicated for you. Then on each drawing with excellent frames, it's 3 rails per main column. If we had only outlined the first column with 3 rails, we would have given you a set with 2 rails. So be careful that there are some projects that aren't simple, but we indicate the 4 PV racks for you. Or if you have 3 PV racks, we specify that they're not aligned for spreading. Then, of course, you need to check between the plans we've sent you, the 4 complete pile layouts, and your own roof. That's it for these roofing examples. All right, we're almost at the end of the presentation with a few reminders. No overlapping directly above a purlin. The maximum cantilever for a module is 50 centimeters, but your upper generator rails will be 70 centimeters from the purlin, and your lower generator rail will be 59 centimeters. Your PV clamps 4N. A fixed point is actually these 2 small Torx 20 screws for each rail. And that's it. You have remote training sessions and now also directly online. Don't hesitate to check out our website. You can easily go to our website, sign up directly in our client area, and create quotes online. You really shouldn't hesitate to do it. We have a rather small yet incredibly efficient search engine available on our website, and it actually lets you quickly and easily check if your specific module is fully certified with our comprehensive system. So if you've already carefully chosen your particular module, you can then quite easily certify the system and thoroughly check its overall compatibility. For example, I'll simply type in my J, and it will then diligently search for one of the relevant references for you. So I'll just type in any one of them right here. You'll see, though it's not certain that it will show up on Helios B², but we'll see. Let's try this one, for example. It loads for you and checks with which system you are certified, whether you're in the OPN science certificate, if you're in the technical documentation, and with the power classes. So it's really interesting, and with our different systems as well. Don't hesitate. After watching this, if you still have questions, if you have any questions, you can send them to me via my email address. Be sure to mention which system you have, and if you have an ongoing file. If you want us to discuss the file as well, please give me the file number. It starts either with the letter F or the letter E. And if you would like a training certificate, please let me know in your email. Include your name and your company's address, the date you watched this training, and the system you viewed. There you go. Well, I wish you a very good day and a good start to your project. Thank you. Goodbye.